Fifth grade lesson 1.5 is multiplication patterns. Our essential question is, how can you use a basic fact and a pattern to multiply by a two-digit number? Well, let's unlock the problem. How close have you been to a bumblebee? The actual length of a queen bumblebee is about 20 millimeters. The photograph shows part of a bee under a microscope at 10 times its actual size. What would the length of the bee appear to be at a magnification of 300 times its actual size? So how would we go about doing that? Let's see. We can use a basic fact and a pattern. If we were to multiply 300 times 20, let's use the basic fact of 3 times 2. This is kind of a review. You kind of remember this from previous year. 3 times 2 will give us 6. And then if we wanted to be 30 times 2, we'd do 3 times 2 times 10 to the 1 power, which would give me 60. If I wanted 300 times, then that's going to be 3 times 2, which gives me 6, times 10 to the second power, so that's going to be 600. And if we're doing 300 times 20, because this is where we were at here, that's 3 times 2, which is 6, times 100 times 10, or 10 to the third, and that is going to give us 6,000. So the length of the bee would appear to be about 6,000 millimeters. What would the length of the bee shown in the photograph appear to be if the microscope shows it at 10 times its actual size? Okay, well, let's think about it. We have the actual size as 20 millimeters. 10 times its actual size is going to be times 10, or 10 to the 1. And 20 times 10 is 200. So it would be 200 millimeters. Let's use mental math and a pattern for 50 times 8,000. We'll use the basic math fact of 5 times 8 because we know that will give us 40. That's our basic one, 40 with a 1 0 there. If we did 5 times 8 times 10 to the 1, that means we're going to have one extra 0 on there. So we have the 40 from the 5 times 8, and then one extra 0 from the 10 to the 1 power. What if we did 5 times, to get 5 times 800, if we did 5 times 8, that's 40, right? Let's go ahead and write 40. And then that's times 10 to the second power. That's 10 times 10, which is 100, so 2 extra zeros on the end. That is 4,000. 50 times 800 is going to be the 5 times 8, the basic fact, which is 40. And then 10 times 100, or 10 times 10 times 10, or 10 to the third power. That's 3 zeros on it. 1, 2, 3, 40,000. And finally, 50 times 8,000, we use our basic fact, 5 times 8, to get 40. And then I'm doing that 10 times 1,000, or 10 times 10 times 10 times 10. That's 10 to the fourth. 4 zeros on the end. 1, 2, 3, 4. For 400,000. So that's just the pattern thereafter. Just keep in mind when we have exponents with that base being 10, it makes it really easy because we're just talking about how many zeros are we talking about. Let's practice some of these. We were going to use mental math and a pattern to find the product. We're doing 30 times 4,000. Use the basic fact of 3 times 4. And as you know, 3 times 4 is 12. And we have 4 zeros, so that's going to be 10 to the fourth. So we could say 12 times 10 to the fourth, which is the same as 12. Oopsie. 12 with 4 zeros. 1, 2, 3, 4. 120,000. What basic fact can you use to help you find 30 times 4,000? I would do 3 times 4 times 10 to the 1, 2, 3, 4th place, fourth power. Now they want us to use mental math to complete the pattern. We have 1 times 1 is 1. That's easy. 1 times 10 to the 1 That's a 1 with a 0 on the end, 1 0 on the end. So 1 times 1 is 1 with a 0 on the end. 1 times 10 to the second, our basic fact is 1 times 1 with the power of 2, meaning 2 zeros on the end for a base 10. 1 times 10 to the third, 1 times 1 is the basic fact, 1. And then 10 to the third is 3 zeros on the end, like that. As long as the base is 10, then that's a nice easy rule to do. Let's look at this one. 7 times 8 is 56. So if I have 7 times 8 times 10 to the 1, I'm going to have 56 with 1 0 on the end. On this next one, 7 times 8 times 10 to the second, go ahead and put it down. So I get 56, 56. And 10 to the second is 10 times 10, 100, so I have 2 zeros. 7 times 8, 56 on this one, times 10 to the third, 10 times 10 times 10, that's 1,000. 1, 2, 3 zeros. Let's look at this one. This might throw you off a little bit, but just watch closely. 6 times 5, 30. It already has a 0 as part of its product, so it's not going to count in the zeros we were talking about over here. 6 times 5 times 10 to the what gives us 300. Well, remember, this 0 here is part of 30, so it has 1 extra 0, so that's a 10 to the 1 power. 6 times 5 is 30, times 10 to the what? If I have 3,000 as my answer, 30 was part of the whole product of 6 times 5, so it's got 2 extra zeros on the end. That's 10 to the second. 6 times 5 is 30, and times 10 to the what? If I have 30 as my product, there's 1, 2, 3 extra zeros, so it's times 10 to the third. So the purpose of this lesson is really just to get your brain familiar with these basic facts being compared or multiplied by these powers of 10, the 10 times 10 times 10, and using the exponent to represent that. So hopefully that makes sense to you and you're ready for Think Central. Good luck.